We've already seen how the chain rule works, and what I want to do is just show you a shortcut. It's not for everybody. Some people will continue to do it using the longer chain rule, and as long as you get the answer right, that's quite okay. You don't have to do the shortcut, but some of you that will get very proficient at doing these will use a shortcut all the time after you get used to it. So let's do it by the way we know right now. So we've got y equals 1 over x cubed plus 3x to the power of 4, and you say, well, what rule am I going to use? At the moment, it looks like it's going to be chain rule. It doesn't look too good with the 1 over, so what we might do is bring this upstairs, and if we bring it up and it's positive power downstairs, it'll be a negative power upstairs. So we'll put x cubed minus 3x to the negative 4. Okay, so if I was to give you a value of x, you would substitute inside the brackets first, and then you would raise that to the power of negative 4, which is like taking it downstairs and raising it to the positive 4. So this is going to be my u, what's inside the bracket. So let u equals x cubed minus 3x, so we can straight away go du dx, and that'll be 3x squared minus 3 when we find the derivative of that, and you've got y equals u to the minus 4, so dy du is equal to, now bring the power to the front, minus 4u, and then we take 1 off the power, negative 4 take 1 is negative 5. And probably for simplicity, we'll put the u down with a positive 5, so that's minus 4 over u to the power of 5. Okay, so then we quote the chain rule, dy dx is equal to dy du times du dx. That's just quoting the rule. And dy du is negative 4 over u to the power of 5 times du dx, and once again we probably should put this in brackets, 3x squared minus 3. Okay, and we can multiply out the top, leave the negative at the front, and we've got negative 12x squared, okay, if we got the negative out the front, we're just going to multiply by a positive 4, so let's leave that like that. So we're leaving the negative out the front, and if you like, we've got another bracket like that, and so we just multiply the positive 4 times that, 12x squared minus 12 all over, now u to the power of 5, u is x cubed minus 3x, so it'll be x cubed minus 3x all raised to the power of 5. Okay, and that's about as far as you need to go. All right, you could incorporate that and put the negative up there, and you'd put negative 12x squared, so instead of writing the negative at the front, it'd be negative 12x squared plus 12. 6 of one, half a dozen the other as to what you do. Leave it like that. That's probably just as easy. All right, now the shortcut, and I like the acronym DIDO. DIDO stands for diff in, diff out. DIDO. Now, what's diff in mean? Means if I go up here to, I've got y equals x cubed minus 3x all raised to the power of 4. So here's my function. Diffing in is like diffing inside the brackets. So I'm going to just go straight for the answer here. Dy dx equals, diffing in is like diffing inside the brackets. And when you find the derivative of what's inside the brackets, you get 3x squared minus 3. Now put that in brackets as well. So that's diffing in. Now when you diff out, if we go back up here again, when we diff out, if you like, put your thumb or your finger over what's inside the brackets, and what's the derivative of something to the power of -4? Just think of what's in the brackets as just like an x. X to the power of -4. Well, what do? You bring the -4 down to the front. So we'll bring -4, and then whatever's in the brackets, we write again, and we take 1 off that power. So that's -4 take 1 is -5. And we've got to write what's inside the brackets. And then when we multiply the -4 times that, we get -12x squared plus 12. And then this to the -5 is downstairs to the positive. And that's probably as far as you need to go. We could actually, I'm just trying to get over there, but you can see that this answer here, well, if we did go that extra step over here, the negative, that's a positive in front, so that negative will make that positive into a negative, -12x squared, and that negative will make that negative into a positive. And hopefully, have we got the same answer? Yes, we have. Okay, so you can see it's much quicker. You don't obviously write this out, but it's a matter of diffing in. Diffing in is diffing inside the bracket, so diffing inside up here, and we get that. You've got to use brackets. Put brackets when you do this. Then it's -4. Just imagine what's in the brackets is like something to the power of -4. Well, it's -4 something to the -5. Take 1 off, and we get that there. So that's how we get that. And then we can combine these two together. We can't combine that. That's to the -5, so it's got to come downstairs to the +5. And we just multiply out -4 times that. So maybe we do one more example, and I'll just do it using the shortcut. So if we've got y equals natural log of 3, we like the 3, so 3x to the 4 minus 2. Okay, now, first of all, we recognize that it's going to be a chain rule problem because we've got two functions going on. We've got 3x to the 4th minus 2 is my first function, and then we find the log of the answer. Whenever we work out the bracket, then we find the log of the answer at the end. So what's diffing in? Diffing in is diffing what's in here. And inside the brackets, when we diff in, we get 12x cubed. That's diffing in, and it's always connected by multiply. And we don't have to put brackets around that. If this was 2x here, we'd have -2 here and put that in brackets, but we don't have it. We've just got a single term, so we don't need to put the single term in brackets. When we diff out, we say, what's the derivative? We know our table of derivatives. The derivative of ln of something is 1 over that something. So it's 1 over 3x to the 4th minus 2. So that's diffing out. And that can be simplified as 12x cubed over 3x to the 4 minus 2. And we know, don't we, that we can't cancel that 3 and that 12 or 3x to the 4th and that, because this has got another term here of minus 2. This is an expression here. So we can't cancel any of that there. That is my answer. Leave it as it is there. So there we go. Makes it much easier, but it's not going to be easy if you get the wrong answer. So if you're not confident with knowing how to use diff in, diff out, stick to the chain rule using a little bit longer, but you will always get the right answer if you apply the rule properly. So don't feel as though you have to use a shortcut with the chain rule.